This lecture is about the evaluation of text categorization. So we've talked about many different methods for text categorization, but how do you know which method works better? And for a particular application, how do you know this is the best way of solving your problem? To understand these, we have to know how to evaluate categorization results. So first, some general thoughts about the evaluation. In general, for evaluation of this kind of empirical tasks, such as categorization, we use a methodology that was developed in 1960s by information retrieval researchers called the Cranfield evaluation methodology. The basic idea is to have humans to create a test collection where we already know every document is tagged with the desired categories, or in the case of search, for which query, which documents should have been retrieved. And this is called ground truth. Now, with this ground truth test collection, we can then reuse the collection to test many different systems and compare different systems. We can also turn off some component in the system to see what's going to happen. Basically, it provides a way to do controlled experiments to compare different methods. So this methodology has been virtually used for all the tasks that involve empirically defined problems. So in our case, then, we are going to compare our system's categorization results with the categorization ground truths created by humans. And we're going to compare our system's decisions on which documents should get which category with what categories have been assigned to those documents by humans. And we want to quantify the similarity of these decisions, or equivalently to measure the difference between the system output and the desired ideal output generated by the humans. So obviously, the higher similarity is, the better the results are. The similarity can be measured in different ways, and that would lead to different measures. And sometimes it's desirable also to measure the similarity from different perspectives, just to have a better understanding of the results in detail. For example, we might be also interested in knowing which category performs better, which category is easy to categorize, etc. In general, different categorization mistakes, however, have different costs for a specific application. So some errors might be more serious than others. So ideally, we would like to model such differences. But if you read many papers in text categorization, you will see that they don't generally do that, and instead they will use a simplified measure. And that's because it's often okay not to consider such a cost variation when we compare different methods, and when we are interested in knowing the relative difference of these methods. So it's okay to introduce some bias as long as the bias is not correlated with a particular method. And then we should still expect a more effective method to perform better than a less effective one, even though the measure is not perfect. So the first measure that we will introduce is called classification accuracy, and this is basically to measure the percentage of correct decisions. So here you show that here you see that there are k categories denoted by C1 through CK, and there are n documents denoted by D1 through Dn. And for each pair of a category and a document, we can then look at the situation and see if the system has said yes to this pair, basically has assigned this category to this document, or no. So this is denoted by Y or N. That's the system's decision. And similarly, we can look at the human's decision also. If the human has assigned a category to the document, then there will be a plus sign here. That just means the human would think this assignment is correct. And if it's incorrect, then there's a minus. So we will see all combinations of these n's, yes and no's, with minus and pluses. So there are 4 combinations in total, and 2 of them are correct. And that's when we have y plus or n minus, right? And then there are also 2 kinds of errors. So the measure of classification accuracy is simply to count how many of these decisions are correct and normalize that by the total number of decisions we have made. So we know that the total number of decisions is n multiplied by k, and the number of correct decisions obviously are basically of two kinds. One is y pluses and the other is n minuses, and we just put together the counts. Now this is a very convenient measure that will give us one number to characterize performance of a method, and the higher the better, of course. But the method it also has some problems. First, it has treated all the decisions equally. So, but in reality, some decision errors are more serious than others. For example, it may be more important to get the decisions right on some documents than others, or maybe more important to get the decisions right on some categories than others. And this would call for some detailed evaluation of these results to understand the strengths and weaknesses of different methods, and to understand the performance of these methods in detail in a per category or per document basis. One example that shows clearly the decision errors are having different causes is spam filtering. That could be treated as a two-category categorization problem. Missing a legitimate email is one type of error, but letting a spam to come into your folder is another type of error. The two types of errors are clearly very different, because it's very important not to miss a legitimate email. It's okay to occasionally let a spam email to come into your inbox. So the error of the first, missing a legitimate email, is is of high cost. It's a very serious mistake. And classification error, classification accuracy does not address this issue. There's also another problem with imbalanced test set. Imagine there's a skewed test set where most instances are in category 1, and 98% of instances are in category 1. Only 2% are in category 2. In such a case, we can have a very simple baseline that actually performs very well, and that baseline would simply put all instances in the major category. That would give us 98% accuracy in this case. It's going to be appearing to be very effective, but in reality, this is obviously not a good result. Right? And so, in general, when we use classification accuracy as a measure, we want to ensure that the classes are balanced. And we want about equal number of instances, for example, in each class. The minority categories or classes tend to be overlooked in the evaluation of classification accuracy. Now, to address these problems, we of course would like to also evaluate the results in other ways and in different ways. As I said, it's beneficial to look at the actually multiple perspectives. So, for example, we can look at the perspective from each document, perspective based on each document. So the question here is, how could other decisions on this document? Now, as in the general cases of all decisions, we can think about the 4 combinations of possibilities, depending on whether the system has said yes and depending on whether the human has said correct or incorrect or said yes or no. And so the 4 combinations are, first, when both the human and the system said yes, and that's true positives. When the system says yes, it's actually positive. So when the system says yes, it's a positive. But when the human confirmed that it is indeed correct, that becomes a true positive. When the system says yes, but the human says no, that's incorrect. That's a false positive, FP. And when the system says no, but the human says yes, then it's a false negative. We missed one assignment. When both the system and human said no, then that's also a correct decision. That's true negatives. Right. So then we can have some measures to just better characterize the performance by using these 4 numbers. And so 2 popular measures are precision and recall. And these were also proposed by information retrieval researchers in 1960s for evaluating search results, but now they have become a standard measure used everywhere. So when the system says yes, we can ask the question, how many are correct? What's the percent of correct decisions when the system says yes? That's called precision. It's the true positive divided by all the cases when the system says yes, all the positives. The other measure is called recall, and this measures whether the document has got all the categories it should have. So in this case, it's to divide the true positive by true positives and the false negatives. So these are all the cases where the human says the document should have this category. So this represents all the categories that it should have got. And so recall tells us whether the system has actually indeed assigned all the categories that it should have to this document. This gives us a detailed view of the decisions on each document. Then we can aggregate them later. Right? And if we're interested in some documents, and this would tell us how well we did on those documents, a subset of them might be more interesting than others, for example. And this allows us to analyze errors in more detail as well. We can separate the documents of certain characteristic from others and then look at the errors. You might see a pattern, hey, for this kind of documents, this is long documents, it doesn't do as well as for short documents. And this gives you some insight for improving the method. Similarly, we can look at the per category evaluation. In this case, we're going to look at how good are the decisions on a particular category. And as in the previous case, we can define precision and recall. And it will just basically answer the questions from a different perspective. Right? So when the system says yes, how many are correct? That means looking at this category to see if all the documents that are assigned with this category are indeed in this category. Right? And recall would tell us, has the category been actually assigned to all the documents that should have this category? It's sometimes also useful to combine precision and recall as one measure, and this is often done by using an F measure. And this is just a harmonic mean of precision and recall defined on this slide. And it's also controlled by a parameter beta to indicate whether precision is more important or recall is more important. When beta is set to 1, we have a measure called F1, and in this case, we just take equal weight on both precision and recall. Right? F1 is very often used as a measure for categorization. Now, as in all cases, when we combine results, you always should think about the best way of combining them. So in this case, I don't know if you have thought about it, and we could have combined them just with the arithmetic mean, right? So that would still give us the same range of values. But obviously, there's a reason why we didn't do that, and why F1 is more popular. And it's actually useful to think about the difference. And if you think about that, you will see that there is indeed some difference and some undesirable property of this arithmetic mean. Basically, it will be obvious to you if you think about a case when the system says yes for all the category and document pairs. And you can try to compute the precision and recall in that case, and see what would happen. Right? Basically, this kind of measure will the arithmetic mean is not going to be as reasonable as F1, which tends to prefer a trade-off between precision and recall, so that the two values are about equal. So if there's an extreme case where you have 0 for one value and 1 for the other, then F1 will be low, but the arithmetic mean would still be reasonably high.